In biological studies, binding curves describe how ligand concentration affects receptor occupancy. These curves reflect either receptor occupancy, as the fraction of receptors bound, or as a physiological response produced by exposure to a stimulus. With such versatility, binding curves underlie our understanding of drug interactions and are used to characterize many types of therapeutic potentials, such as the half maximal effective concentration, inhibitory concentration, or effective dose. Binding curves have also been used to describe toxicity with the median lethal dose, a value that quantifies the exposure limit which would be fatal to half of a test population. As indicated by their names, the equation for these binding curves is defined by a constant equal to the concentration of ligand that produces 50% receptor occupancy or physiological response. In the case of the half maximal inhibitory concentration, the constant is known as the IC50 value. While binding curves are the simplest way of characterizing biological interactions, the mass action principles governing interaction between ligands and receptors makes the binding curve a very useful tool for understanding and quantifying most natural interactions. But why has this form of modeling become so prevalent? Do these simple models mask more complex interactions? Why have more complex models been ignored in favor of binding curves? As it has been suggested that every biological system deserves its own detailed model, have these alternative modeling approaches overcomplicated things favoring the simplicity of binding curves? And has institutionalized regulatory support for simple binding curves hampered development of a more nuanced understanding of biological interactions? These are some of the topics I plan to explore on this channel, so thanks for watching, subscribe, and leave a comment below, as I would love to hear what you have to say about issues surrounding biological and biochemical studies.